So the next thing that affects blood pressure is stretch. So that stretch of the heart walls. So there's this law called the Frank and Starling law. And Erno Frank and Otto Starling were two scientists, or dead guys, that discovered this this process within the heart that affects blood pressure. So their law states that the amount of stretch experienced by a cardiac muscle, or by cardiac muscle cells, plural, increases tension in the muscle and thus increases the force of contraction. So basically, increased stretch equals increased force of contraction. So how do we get increased stretch? So we're talking about in the ventricle, in the heart, how do we get increased stretch? Well, we need to fill it more to get increased stretch. So we have basically stretch. How can we quantitate stretch? So we said that stretch comes from, or increased stretch comes from, filling the ventricles more. So it would make sense that to quantitate that, we would look at end diastolic volume. Because at end diastolic volume, you would have the ventricles would be filled the most. So if, let's say, max, or around max, is about 400 milliliters, and let's say at being relaxed is about 135 milliliters. So if we have stretch on this side, and we're looking at force, the force of contraction. So how could we quantitate, for lack of a better word, force? So how do we look at, what can we look at for force? Well, force can be looked at in stroke volume. So the higher the stroke volume is, the more force was used to get more blood out. Okay, so if we have normal or at relaxed, we'll say the stroke volume is about 70. So this would be like relaxed heart here, normal relaxed heart. So as we increase end diastolic volume, or increasing stretch, as that happens, it just so happens that Ernest and Otto figured out that the stroke volume increases to a point. Okay, so increasing end diastolic volume, that increases the stretch on the walls of the heart, that increases the force of contraction. So substances that cause this increased contraction or increased force are called inotropic factors. So these are factors that affect force of contraction. So stretch is an inotropic factor. So how do we get this? How do we increase end diastolic volume? So we're filling it more, we're filling the ventricle more. So what we need is to increase venous return. The more blood that goes back into the heart, the higher the end diastolic volume, the higher the stretch, the higher the force of contraction, the higher the pressure, the blood pressure. So preload and afterload have an effect on this. So if we remember that preload was the stretch experienced by the ventricle. Which makes sense. So we stretch it. That's the preload. It snaps back. It's kind of like taking a rubber band and pulling it. The further you pull it, the harder it's going to snap back onto your finger. The shorter you pull it, the easier it's going to snap back, with less force. So the preload is the filling. So the stretch experienced in the ventricle by filling with blood. Afterload is related to resistance, of course. So this is resistance to blood flow after systole. This is what has to be overcome. The resistance that has to be overcome at systole. For the blood to move. So in this case, it's the semilunar valves. That is the resistance of the blood. The blood has to push those valves open for them to enter the aorta or the pulmonary trunk there. So afterload is working against the force of contraction. Preload is the build-up to what the force of contraction is going to ultimately be, and that depends on the stretch. Okay, so now we're going to look at a different aspect of what affects blood pressure.